Dear student, in our previous lecture, we have actually discussed about the different types of scale, that is scale, how scale is produced due to calcium carbonate, from calcium bicarbonate, calcium sulfate, scale due to silica, and how this scale can be removed. We could not actually discuss that day because of time constraint. So let us first discuss how scale of different type can be controlled, and then we'll proceed further. So, scale can be removed. Actually, we have seen if the scale or sludge, whatever it may be, is not hard by using a piece of wood or scraper. Try to understand that. If the scale is not very hard, it is slimy type of thing, then it can be removed by using a piece of wood or a scraper. Now, if the scale is brittle in nature, brittle, you understand brittle, which breaks down immediately, so then it can be removed by thermal treatment. Then what is thermal treatment? It is actually heating followed by sudden cooling. Try to understand. This treatment is known as thermal treatment. If your scale is brittle in nature, then it can be removed by actually thermal treatment, and thermal treatment is we have to heat it and it will be followed by sudden cooling, and because of that brittle kind of scale can be removed. Now third one, if the scale is hard, number one, and due to calcium carbonate, so this kind of scale can be removed by using 5 to 10% hydrochloric acid. You can understand, actually calcium carbonate will get dissolved in hydrochloric acid, producing soluble calcium chloride. And if the scale is due to calcium sulfate, then this kind of hardness can be removed by using EDTA solution. Actually, EDTA, full form of EDTA, ethylene diamine tetraacetic acid, while this kind of actually chelating agent reacts with calcium to produce a soluble complex. And this is how we can remove scale of different types. One more thing I would like to tell you, another process, physical process is also available, which is known as blow down operation. Blow down operation. What is blow down operation? The best option of removing scale and sludge, not actually removing, best option to control scale and sludge formation is blow down operation. What is that? Suppose this is your boiler. I have told earlier also, suppose capacity is 1000 liter. Hardness is 1 ppm. Heating is started. Steam will go out. Water level will go down. When it comes down to 10 liters, we stop heating. Now what we do? As we have seen earlier, initially hardness was 1 ppm. Now the hardness of this 10 liters water will be multiplied by, you understand that, 100 times. That is 10 into 100, it will be 1000 ppm. So what we will do? Suppose we will keep a pipeline here. Once the volume of water is reduced to 10 liters, this valve is opened and entire 10 liters of water will be thrown out of the boiler. As a result, there will be no more highly concentrated water. Then again let us take 1000 liters of water, and every time we will do like that. This kind of operation is known as blow down operation, and this is the best option how we can actually control or monitor scale and sludge formation. Now, another actually type of boiler problem was caustic embrittlement, which we have already discussed. Now boiler corrosion. This is our direct problem as far as boiler is concerned. And how corrosion takes place we have seen earlier. Basic principle is like that only. Iron will get oxidized by losing 2 electrons, and these 2 electrons will be accepted by oxygen in presence of water to produce 2OH minus, and in this process Fe2 plus will react with 2OH minus producing FeOH whole bracket 2, and if sufficient oxygen is available, as we have seen earlier, it will be further oxidized to ferric hydroxide, and it corresponds to Fe2O3 and 1 molecule of water. This is known as rust. This is how actually corrosion proceeds in boiler. We have seen earlier also. Now we have to see how this kind of corrosion can be controlled. If we carefully observe, we have to identify there are some components which are mainly responsible for boiler corrosion. And first culprit, as far as corrosion in boiler is concerned, is your oxygen. If oxygen in water can be controlled, dissolved oxygen in water can be controlled, so automatically this kind of corrosion can be controlled. How we can do that? You know that. That is due to oxygen. As we know, oxygen is an oxidizing agent. If we can add some suitable reducing agent, they will react together. Suppose if we use calculated amount of sodium sulfide and H2O3 or sodium sulfide, so both of them will react with oxygen to produce H2O4. During this, dissolved oxygen in boiler water will be consumed. As a result, oxygen reaction, corrosion due to oxygen, this kind of reaction will be stopped and corrosion can be controlled. Second one, due to carbon dioxide. We know that boiler water may also contain dissolved carbon dioxide. And carbon dioxide, if it is present, it will react with water to produce H2O3, carbonic acid. As we know that carbonic acid, being weak acid, it will ionize to some extent, making your boiler water slightly acidic. In acidic situation, rate of corrosion is very, very high. And this kind of corrosion can be controlled by removing carbon dioxide, and for that, what you can do, we can use calculated amount of ammonia, which will react with carbon dioxide to produce ammonium carbonate. And this is how corrosion due to dissolved carbon dioxide in water, in boiler water, can be controlled. And last one is due to salt like magnesium chloride. It is very, very dangerous. Whatever we are going to use in boiler, it contains dissolved magnesium chloride. Now this magnesium chloride will get hydrolyzed during boiling to produce magnesium hydroxide plus hydrochloric acid. Now this hydrochloric acid will attack your iron. Iron being one of the basic component of your boiler. And as during this, FeCl2 and hydrogen will be released. Now this FeCl2 will again be hydrolyzed to produce ferrous hydroxide and hydrochloric acid. It will make a chain reaction. Every time hydrochloric acid will be formed and it will attack iron of the boiler. As a result, it will make a chain reaction and corrosion will be continued. And most best way to control this kind of corrosion is that we have to ensure right from the beginning water to be used in boiler must free from magnesium chloride. This is all about boiler corrosion which takes place directly. Now two more things are left. Number one is priming and number two is foaming. And to discuss with, let us talk about priming. What is priming? In this context, I would like to give you one example. All of you might have seen some kind of defective pressure cooker. You might have seen. You know the mechanism of pressure cooker. You put things inside, close it, heating is started. When pressure reaches 15 pound, then you know that water steam will be produced, it will exert pressure, and when it reaches 15 pound, then actually the whistle at the top will start blowing. This is the mechanism. But you might have noticed some defective kind of heat, that is pressure cooker, where the whistle is found to keep on dancing. It never actually give whistling. And if you carefully observe, you will see that this kind of things always releases some water through this channel from the top. What does it mean? The water vapor, which is supposed to exert pressure, is condensed and is coming out in the form of water. And because of that, pressure can never be reached to 15 pound, and therefore the whistling is not there. This is the basic principle. If we want to explain it more precisely, let us see. Suppose it is a water container, water is there. Try to understand that. This much water is there. Suppose this water contains dissolved salt. Heating is started. After some time, water will start boiling. Once water starts boiling, steam will be produced and it will go out. Here I would like to tell you another example. Suppose it is another container, pure water is taken, pure distilled water, say. Now heating is started. After some time it will start boiling, and if you carefully observe, you will see something on the surface of water layer. What you will see? Very small bubble will appear and it will break down immediately. It is like that. Water is very, very pure, free from any kind of salt. But here, since water contains dissolved salt, the water bubble that will be produced on the surface will not be exactly the same. To make it understand, let us take another example. Suppose this is the pure water and very small particle after boiling appeared on the surface. Now we have added some rice. What will happen? For some time, boiling of water will be suspended, and after some time, again boiling will be started. Now if you carefully observe you will see that water bubble will be produced. Now the water bubble, size of the water bubble will be bigger. Initially water was absolutely pure. Very small water bubble appeared on the surface, but once rice is used, now water particle, that is water bubble of bigger size will appear and they will be jumping like anything. And from this observation it is very much clear, if water contains any dissolved or undissolved type of substance in it, the water bubble that will be produced will be bigger in size. If water is pure, very small bubble will appear. If soluble or insoluble substance is there, water bubble of bigger size that will appear. So now let us use this concept here. So since this water contains dissolved salt, steam is going out. So on the surface of the water bubble of bigger size will be produced, and they will be jumping like anything. And during jumping, there is every possibility steam is going and there is every possibility water bubble will come on the way of the steam going out. And if they comes in contact, what will happen? Let us see. Your steam is gas. Water bubble is liquid. So if a gas comes in contact with a liquid, your gas will become wet. This kind of wet steam formation, I repeat, this kind of wet steam formation is known as priming. The defective pressure cooker, remember, steam was going out, but because of dissolved salt, water bubble was also jumping. That water bubble comes in the way of actually steam and made the steam wet, as a result of which steam, being a gas, will get condensed and it will come out in the form of water once again through the cushion. That is the main problem. That was the main basic problem. And this kind of actually wet gas, that is steam formation, is known as priming. Now we have to see what is the reason of priming. What is the main reason of priming? Reasons are, number one, dissolved salts in it. Number two, improper boiler design. If the design of the boiler is not proper, then also it can happen. Number three, rapid production. You might have seen, if you take a small container, suppose water is boiling, so suppose some amount of rice you have added, flame is controlled, bubble of bigger size will be formed and they will be jumping moderately in between. But suddenly, if you increase the flame, jumping of the water bubble will be increased and they will be jumping like anything. Similarly, this is known as rapid production. Because if we want to produce more steam in a short time, then what we have to do? We have to increase the actually energy density. And during this is what is known as rapid production. And number four is sudden change in production rate. Suppose you are producing steam at a rate of 100 liters per hour. Because of huge demand, you have to, if you are required to do it 200 liters per hour, then you have to change it from 100 to 200, and therefore this is sudden change in production rate. This may also call this kind of priming. Now, how can you control this priming? Because priming can be controlled. There are two different ways you can control priming. Number one, by using water of specification, as we discussed earlier. And number two, by using mechanical steam purifier. Your steam, try to understand, the steam has become wet. So if you use mechanical steam purifier, it will absorb the liquid water, and therefore your steam will become gaseous again. And therefore, by using mechanical steam purifier, you can do it. And number two, avoiding rapid change in production rate, we can control priming. This is all about priming. Now let us see foaming. It is very, very important, and try to understand that. And to make you understand, let us take one simple example. Take a glass of water and an empty glass. You do like that. After some time, if you carefully observe, you will find very small bubble appear on the surface of water and they will break down immediately. Repeatedly, if you do like that, same thing will appear. Now you take a glass of milk and an empty glass, and if you do like that, and if you observe carefully after some times, you will see bubbles of smaller size appeared on the surface of the liquid and they are not breaking down immediately. The difference between water and milk is that in case of water, bubble breaks down immediately, but in case of milk, it is not breaking down immediately. This kind of bubble which is being formed and do not collapse immediately is known as foam. And therefore, sometimes we say, every bubble is not foam, but every foam is bubble. To become foam, it is to be a bubble. Bubble which is formed and do not collapse immediately, then only it is known as foam. And the process of this is known as foaming. And reason of foaming, you can understand the difference between water and milk is what? Milk contains fatty material, oily material. The reason will be presence of oily material in water. If you use in boiler, they are going to produce foaming also. One of the most important thing I have forgotten to tell you, if anybody asks what is the consequence of foaming, the most important thing is that if priming or foaming is there, it will be very difficult to maintain pressure in boiler. As a result, pressure cannot reach to the desired level. And how foaming can be controlled? And if you want to control foaming, we can control it by using anti-foaming agent like castor oil or salt like sodium aluminate. This is how we can control foaming. This is all about, in brief, boiler problems, the reason of boiler problems, and how we can monitor and control boiler problems. I hope I have covered major parts. Please go through the video very carefully. In case you have any doubt, get it noted. Definitely we'll try to clarify your doubts in our next lecture.